Perhaps the biggest frustration in music making that we all face is the ease with which we can hear a sound in our head and the frustrating process of getting a synth to actually make that sound. So today, I wanted to show you how to make a synthesizer patch that has been highly requested, but in the process, we'll be looking at the considerations that go from getting the sound we hear in our head to the one we hear on the speakers. Today, let's make a dirty Reese Bass. You know, the ones that go... Modern Reese basses actually encompass a huge variety of sounds made in a huge variety of ways, but at their heart, Reese basses are all harmonically rich synth tones that are distorted, compressed, and filtered to result in an aggressive, kinetic sound. When doing custom patch design, I always start with a Combinator, which will house any instruments and effects that make up my sound. The first device I drag into the Combinator is usually a line mixer, because custom sounds you make will often have multiple instruments and multiple signal chains. The line mixer gives us a way to group and balance our signals into a single master output. Deep bass sounds often benefit from having what's called a sub-bass included. It's a deep, low frequency that roots any sound on top with some speaker cone rattling fundamental frequency. The best part is that they're usually simple to make. For our sub-bass, let's drag in a Malström synth into the rack, right-click it, and choose Reset Device to clear out the default patch. What we're left with is a simple sine wave, and for our sound, that's actually perfect. Since this is a bass sound, we only want to be able to play one note at a time, so let's set the polyphony to 1. I'm also going to set the pitch bend range to 12 so that bending notes with the pitch wheel moves up and down 1 full octave. And as I go, I try to stay in the habit of labeling devices. Now is where things start to take shape. I'll drag in another Malström and right-click to reset it. If you're new to looking at synths like a blank canvas for your own sounds, it could appear daunting at first, but relax, because despite all these sliders and knobs, right now the only thing that's really making sound is this, Oscillator A. You can see that it's currently set to a sine waveform, which we can change, and we will change. Remember when I said our bass sound needs to be harmonically rich? Well, a sine wave isn't. Here's how it looks on Reason's spectrum display. If we change to a square wave, you can see that we have more harmonic overtones appearing above the fundamental pitch. And you can't just see it. More importantly, you can hear it. It sounds raspier and grittier than the pure sine wave. A sawtooth is made up of every harmonic overtone, and since I want harmonically rich content, that's where I'll start. Malström has 3 options for sawtooth waveforms: the basic sawtooth, and 2 ensemble waveforms, which sound like a quartet of sawtooths playing together, or even a small chamber orchestra of 16 sawtooths. I'll go for that one. Before we move further, let's do some housekeeping like we did with our sub-bass by setting our polyphony to 1, pitch bend range to 12, name our synth Saw 1, and we'll also turn our portamento up a bit to add some glide between notes. You'll see that to the right of Oscillator A is a section called the Shaper. Like its name implies, the shaper reshapes the waveform to alter and often roughen up the sound. We send our oscillator to the shaper by activating this button, which moves our signal along and will turn the shaper on with its on-off button. If you look ahead, following the arrows, you'll see that the next place our signal goes is into the filter, which is also on by default, and since we're not ready for that yet, we'll deactivate it. I can experiment with different types of wave shaping and dial in the amount that I want. I'll go with clip. Let's move on to the filter. We'll turn it on and you'll hear our sound muffle instantly because we've got the low pass filter selected. If I move the frequency knob back and forth, our sound goes from full to muffled. And that's not really what I want. These basses have those sweeping sounds which come from a different type of filter called a band pass filter. To enhance that sweep, we can dial up the resonance. But you can hear we have a new problem because in achieving this sweep effect, we've lost the fullness in our sound. So let's actually use the second oscillator in Malström to create an unadulterated signal that sits underneath our sweeping sawtooth wave. I'll follow a similar process, turning on the oscillator, selecting sawtooth 16. Now when I sweep the bandpass filter frequency, the sound stays full. To enhance the ensemble effect of having 2 oscillators, let's actually detune both oscillators. If we tune Oscillator A slightly sharp in pitch, and Oscillator B slightly flat in pitch, they combine to make a slightly warbling sound. Alright, we're getting there, but let's make it sound cooler now with a series of effects designed to make things angrier, grittier, and, well, Reesier. First up is Distortion. With our Malström selected, I'll drag a Scream 4 into the Combinator, right-click it to clear its default patch, and just change to a slightly rounder tape distortion. Modern Reese Basses have a wide stereo image. One of the quickest ways to get stereo width is with a technique known as the Haas effect, which simply introduces a short delay to one side of the stereo signal, tricking your brain into hearing a stereo sound. To accomplish this, we're going to drag in the DDL1 digital delay beneath our scream and set up the front panel by switching to milliseconds, setting it to something very short, like 17, and dialing the feedback all the way down so we only get one repeat for our sound. Now, most importantly, we're going to rewire it. So let's flip to the back of the rack by pressing the Tab key. If this is your first entry into rack wiring, the beauty of Reason is that the signal flow is right there on display to see. We can see our sub-bass wiring into the mixer's first channel, the sawtooth synth wires into the scream, which then goes out of the scream into the delay, and then out of the delay and up to join our sub-bass in the second channel of the line mixer. Reason has done all this wiring for us. In fact, it will even do rewiring for you too. If we wanted the delay to come before the distortion in this signal chain, we can simply drag the DDL1 above the scream while holding down the Shift key. Let's now disconnect the delay and wire it up to achieve the Haas effect. Remember, I only want to delay one side of the stereo signal, so I'll run a cable from the left output of the Malström to the left input of the delay. If I hold down the Shift key while I'm wiring, I'll avoid Reason trying to help me out by wiring the right channel automatically, which in this case I don't want. And let's now carry the signal on from the left output of the delay to the left input of the scream. The right signal from the Malström should just wire directly to the right input of the scream distortion. If we play a note, suddenly our sound is coming out in wide stereo. Now to make our sound feel bigger, I'm simply going to duplicate that signal chain one more time. I'll drag in another Malström to my Combinator and you can see that it's wired up to the next channel on my mixer. Now I'll drag in my effects, the delay, then the distortion. I'll disconnect the delay again, and holding down the Shift key, I'll wire up only the left side through the delay and into the distortion, and then send the right side of the Malström straight into the right side of the scream for my Haas effect. See how much faster that goes once you're comfortable in the back of the rack? Let's jump around again to the front. We may have wired our signal, but our new devices all have the default patches still loaded on them. I want this second signal chain to sound very similar, but slightly different to the first one. For the Haas delay, we'll set our DDL1 to milliseconds and turn down the feedback, but let's set the delay time to a slightly quicker 14 milliseconds. For the delay, let's actually leave the Easy Fuzz default patch there. And now let's head up to our Saw 1 synth and right-click to copy its patch, which we can then paste onto our newest Malström and modify. Remember the detuning that we did on the first version? Let's enhance that even more on this one. And let's use a different shaper, like Saturate. I'll name this synth Saw 2. These are small changes, but the effect is huge. If I mute the new devices and compare, you can see what a difference that second signal chain makes. With all that done, let's add a little overall tonal shaping to our Combinator with an Audiomatic Retro Transformer. Let's drag one in just below our mixer while holding down the Shift key so it doesn't wire itself. And let's flip to the back of the rack and wire it up so that instead of our line mixer's master output going to the Combinator, it first goes through our Audiomatic, like this. Back to the front, and we'll choose the bottom preset and boost the transform a bit. Finally, let's put a limiter beneath the Audiomatic to even out our sound. Reese Basses these days are known for those sweeping filters and diving pitches. Remember this knob? Well, we want to sweep that knob on two different synths at the same time, which is where the Combinator comes in perfectly. The Combinator contains its own set of assignable buttons and knobs which can be set up to control the devices inside. If we open up the programmer, we'll see all the devices in our Combinator. Let's select the Saw 1 synth and tell it that the Combinator's first rotary knob will control the Filter A frequency knob. You can see that as I move rotary 1, the knob on our Malström moves in tandem. Now let's select Saw 2 and set the same rotary 1 knob to control its own filter A frequency knob. But since we're making the second saw slightly different, let's change the minimum and maximum values from the knob's full range to a reduced range of motion. Now when rotary 1 is at its maximum, Saw's 2 frequency is here, and when rotary 1 is at its minimum, Saw 2 is here. This means that the two filters will sweep from one knob, but within a different part of their range. I'll label my rotary knob Filter, so it makes sense. And let's start using the synth in my song. My Reese bass lines involve notes I'll play on the keyboard with heavy filter and pitch automation on top. To set us up for this, let's hold down the Option key or Alt key on Windows and click both the pitch wheel and the filter knob of our Combinator. When we do, you'll see new automation lanes appear in the sequencer. I'll record some basic sustained notes. Now let's add those pitch dives and filter sweeps by drawing in automation in the sequencer. I'll draw in one clip and automate the pitch bend from high back to middle. It's already sounding better. I can now duplicate that pitch clip and experiment to find places it works well within my phrase. I can also trim it, and by holding down the Option or Alt key on Windows, I can stretch or compress how quickly that dive happens. Let's add some filter automation. I'll draw in a combination of slow sweeps and faster sweeps, moving from the minimum to the maximum range of my filter Combinator knob. This pitch and filter automation is where your taste and your style come into play. You'll want to experiment to see what works for you. Let's just listen to that much. Well, it's sounding good so far. Now in this process, you've seen a lot of ways that you can go back and experiment with this sound. What if we chose a different waveform instead of sawtooth, like PWM? What if we use different shaper settings, different distortion, and so on? So I'll leave you here to carry on, experiment, and make your own music with this patch. And you know, I think I'll do the same.